Hello students, welcome back to my channel. So in this class we will discuss valency bond theory VBT. Very important. It explains about overlapping overlapping between atomic orbitals atomic orbitals to form a molecular orbital molecular orbital or molecular orbitals. Okay, here whenever that atomic orbitals will be overlapping each other, here we will get molecular orbital. So for example, we know that atoms are having maximum energy before participating in the chemical reaction. If energy is more, stability is less. So to get the stability, that atoms will be participated in the chemical bonding. Further, here whenever that atomic orbitals will be overlapping each other, means merged each other, then a new molecular orbital will be formed. It means the molecule will be formed. So here, compared to atoms, that molecules are having less energy. The energy is less, then stability will be more. So that's why to get the stability, that atoms will be participated in the chemical bonding, chemical reaction. Understand? So here VBT theory explains about overlapping of atomic orbitals. Here we have two types of overlappings are there. First one is axial overlapping and second one is lateral overlapping. In these two processes, we will get two kinds of bonds. They are sigma bond and pi bond. Sigma bond and a pi bond. Okay, here axial overlapping takes place. Axial overlapping takes place along the internuclear axis. Along the internuclear axis to form a sigma bond. To form a sigma bond. Like that, lateral overlapping means sidewise overlapping. Lateral overlapping takes place either sides of internuclear axis to form a pi bond. Okay, so here two types of overlappings will be occurred. Axial overlapping, second one is lateral overlapping. This axial overlapping also called end-to-end overlapping or head-on overlapping. Lateral overlapping also called as sidewise overlapping or co-lateral overlapping. Understand? So first, what kind of overlapping will be occurred? That is axial overlapping. And then lateral overlapping will be occurred. Means due to the axial overlapping between the atomic orbitals, sigma bond will be formed. Sigma bond is a independent bond. It is independent bond. After formation of sigma bond, pi bond will be formed. So it is a dependent bond. On which bond it will be depend? That is sigma bond. Okay, it is dependent bond of a sigma bond. Understand? Okay, next here the sigma bond is formed by axial or head-on or end-to-end overlapping. But here pi bond is formed by sidewise overlapping. Sidewise or lateral or co-lateral bond. And here the sigma bond compared to pi bond, sigma bond is strong bond. Sigma bond is a strong bond. and it is single bond. And pi bond is weak bond. Weak bond. So we know that in a double bond, one sigma bond is there, one pi bond is there. In triple bond, one sigma bond is there, two pi bonds are present. Understand? So in only sigma bond is only single bond is there means only that is sigma bond. There is no pi bond. In double covalent bond, one sigma, one pi. In triple covalent bond, one sigma, remaining two pi bonds. So yeah, this is the difference between sigma bond and a pi bond. Okay, next formation of O2 molecule. It is very important. We can guess that is formation of O2 molecule and formation of N2 molecule as per VBT theory. Okay, so first formation of O2 molecule. Formation of O2 molecule. So here in this, that overlapping will be occurred between the two oxygen atoms. Two oxygen atoms to form a O2 molecule. How does it form? Now we will see. We know that oxygen atomic number is 8. Its electronic configuration is 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. So in this, what is outermost electronic configuration? 2s2, 2p4. 2s2, 2p4. Okay, here that s orbital contains 2 electrons and p subshell contains 4 electrons. 1, 2, 3, 4. Understand? So here this is 2s, this is a 2px, 2py and a 2pz. So p subshell contains 3 p orbitals. They are px, py and pz orbitals. Understand? So in this, only unpaired electrons will be overlapping each other. Only unpaired electrons will be overlapping each other. So here py orbital overlaps with another py orbital of oxygen. Pz orbital overlaps with another pz orbital of oxygen atom. Okay, here in this, the orbital which is overlapping along the internuclear axis, that will form sigma bond. So remaining orbitals will form pi bonds by lateral overlapping. Understand? For example, if you take a internuclear axis, this is the internuclear axis. Okay, if you take internuclear axis as a py orbital, py axis, so means y axis. If we take internuclear axis as y axis, so here between py sigma bond will be formed. If we take an internuclear axis as z axis, between pz orbitals sigma bond will be formed. That's it. Okay, so here the formation of a sigma bond and pi bond depends on the internuclear axis. Okay, if we take the y axis as internuclear axis, that is sigma bond. Axial overlapping will be occurred. If we take z axis as internuclear axis, so that is between the pz orbitals overlapping will be occurred, then sigma bond will be formed. Okay, here I am taking y axis as a internuclear axis. So then what will happen? Here between py orbitals sigma bond will be formed. Sigma bond will be formed. Between pz orbital pi bond will be formed. That's it. Understand? I am taking y axis as internuclear axis. So then between py orbitals axial overlapping will be occurred, then sigma bond will be formed. That's it. So remaining pz orbital lateral overlapping will be occurred between them. Okay. So now we will see py pz, two orbitals are there having unpaired electrons. Here first py, this is a py orbital and this is a pz orbital. Understand? So they are having unpaired electrons. Unpaired electrons. Like this. Unpaired electrons. Next another one also. This is a first oxygen, this is a second oxygen. Clear? Here also. Here in this electrons should be upward direction. In second one, electrons should be in a downward direction. Understand? Now between these two atomic orbitals, what will happen? Overlapping will be taking place. So this is a along the y-axis means a py orbital. This is py. Along the z-axis means this is a pz. Here also same. It is pz. This is a py. Okay. So then between these two, overlapping will be taking place. Between py. Py, it is also Py of this one. Clear? So then here one upward, one downward, like this. One sigma bond is formed. Here sigma bond is formed between, it is a Py and it is also Py. So between Py, sigma bond is formed. Next, between PZ, what type of overlapping will be taking place? That is lateral overlapping or sideways overlapping. So this is a PZ. So here upward electron, here downward electron. So between these two overlapping will be taking place. Understand? It is a pi bond. This pi bond is formed between PZ. Understand? So here this lateral overlapping will be occurred either side of internuclear axis. This is the internuclear axis. ING means internuclear axis. Here also same. Along the internuclear axis between Py, axial overlapping is occurred, then sigma bond is formed. Okay, either side of internuclear axis means above the internuclear axis, below the internuclear axis. Here overlapping is occurred, then pi bond will be formed. Understand? Above the internuclear axis 50%, below the internuclear axis also 50%. So these two are considered as one pi bond. Understand? Okay. So here in this, how many sigma bonds are formed here? Only one sigma bond. Okay, here one sigma bond, that is sigma Py, one sigma bond. Pi bonds how many here? PZ. So here also one. Okay, sigma bond is formed by axial overlapping. Axial overlapping or end to end or head-on overlapping. Next, pi bond is formed by sidewise overlapping or lateral overlapping. Understand? Okay, so here one sigma bond, one pi bond. So then here two oxygens, one sigma bond, one pi bond. So here each oxygen contains how many lone pairs here? Two lone pairs. 1, 2. Two lone pairs. Clear? It is sigma bond, it is a pi bond. That's it. So this is a formation of a O2 molecule according to VBT. So next, formation of N2 molecule. Formation of N2 molecule. We know that nitrogen atomic number is 7, electronic configuration 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. So in this, tell me here, s orbital contains 2 electrons and p contains 3 electrons. 2 electrons is a lone pair. Next, p subshell contains 3 electrons. So there, this is 2s, this is 2px, 2py and 2pz. So 3 p orbitals contain unpaired electrons separately. Understand? Means these 3 atomic orbitals will be overlapping with another these 3 atomic orbitals of a nitrogen atom to form a 3 covalent bonds. In that first one is a sigma bond and remaining 2 will be pi bond. Understand? Okay, first if I take a internuclear axis as x-axis, then between px, sigma bond will be formed. Remaining py, and pz, pi bond will be formed. Here overlapping must be occurred between the same kind of atomic orbitals. Understand? Between px, between py, between pz only. So there is no occurring of overlapping between px, py and py, pz and pz, px like that. Between dissimilar atomic orbitals overlapping does not occur. Understand? Okay. So here, if I take a internuclear axis as x-axis, then between px, sigma bond will be formed. Understand? So here sigma bond, these two will be formed, pi bond. Understand? Okay, now we will see diagram. Okay. px, py, pz all are having unpaired electrons, upward direction. Understand? So this is what this is a pz, this is py, this is a px. Next, like that, here also same. Clear? So here pz, py and px. So here these are having electrons in downward direction. Okay, we know that between px axial overlapping will be occurred, then sigma bond will be formed. Understand? Clear? Understand? So this is a pz, this is py, this is px. You have the same px, here it is pz, this is a py. So now overlapping will be taking place between here, between px overlapping is occurred already. So here sigma bond is formed. The sigma bond is formed between px. Next to py. This is a p. It is py. Pi bond is formed between py. Next to pz. Pi bond is formed between pz. So here also say py. Next to pz. Understand? So this is formation of N2 molecule according to VBT. So here, how many sigma bonds are formed here? How many sigma bonds? One sigma bond. That is sigma px. How many? One. So how many pi bonds are formed here? Two pi bonds. That is py. And pz, between pz and pz. So here two pi bonds are formed. One sigma, two pi bonds. So totally here the representation is nitrogen, first sigma bond, remaining two pi bonds. At each nitrogen, one lone pair is present. Understand? So here, first one is sigma bond, remaining two are pi bonds. Okay, this is a valency bond theory. Okay, is there any doubt in this concept? You should mention in the comment section. I hope you understood. Thank you.